All right, so let's go ahead and get started. We are going to find the area of a circle, or sorry, given the area of a circle. So if we know that the circle has an area of 153.86 feet squared, we want to find the circumference. So remember, we have to work backwards through the formula. So we know that if we are given area, we can work backwards and find the radius. So we said that the radius can be found by taking the square root of whatever the area is divided by pi. Okay, so we can take the area, divide it by pi, and then take that square root of that answer, and that'll give us the radius. Once we know the radius, we can then double the radius, and that'll give us this, the diameter. Then we can plug it in and solve for the circumference. So it's just kind of like piecing it together, finding out what you know, what's been given to you, and what do you need in order to find the information that you're looking for. Okay, so in this case, we're going to take 153.86 and we're going to divide it by 3.14 first. Okay, when we do that, 153.86 divided by 3.14 is going to come out to 49. And then when we take the square root of 49, so what times itself gives us 49? 7. Okay, so that means that the radius is equal to 7 feet. The radius is going to be equal to 7 feet. Now, we can take that information, and if we take the radius and we multiply it by 2, that's going to give us the diameter. So if we take the radius, multiply it by 2, that'll give us the diameter. So if we take 7 and we multiply it by 2, that's going to give us 14 feet for the diameter. Okay, now that we know the diameter, we can take that and plug it into our circumference formula, because that's what we're trying to look for. We're trying to solve for circumference. So we can take circumference, which is supposed to be equal to the diameter times pi. So all we have to do is multiply 14 times 3.14. And that'll give us our circumference. So what is our circumference for this problem? 43.96. And that is feet. 43.96 feet is the circumference. Okay, so it's basically the idea of looking at the problem and going, okay, they want me to find circumference. What do I need to find circumference? I need the diameter. Well, I'm not given diameter, I'm giving area, and area uses radius. Well, I know I can double radius to get diameter, so I need to find the radius first. Okay, so it's just working backwards through what you want to know and how do you get that information. It's the same thing for problem number 2. For problem number 2, it says the circumference of a circle is 28.26 inches. We want to know what is the area of that circle. So we're given circumference, we need to find the area. So we're going to write down circumference is equal to not circumference. We know that if we want the area, we need to know what the radius is. Well, we don't know what the radius is because we're given circumference, but circumference can tell us the diameter, right? Diameter can be found by taking the circumference and dividing it by pi. We can take the circumference and divide it by pi. So diameter is going to be equal to 28.26 divided by 3.14. Okay, when we do 28.26 divided by 3.14, we're going to get 9. So the diameter is 9 inches. 9 inches. Should say an I, sorry. All right, knowing that the diameter is 9 inches, if we take the diameter and we divide it by 2, that's going to equal the radius. So 9 divided by 2 is going to give us 4.5. So that's the radius. So now we can use that information and plug it into our formula. We can do radius squared times pi. We can do radius squared times pi. So we're going to do 4.5 times 4.5 times 3.14. And that's going to give us our area. So area in this case is going to come out to 63.585, and that's inches squared. Inches squared. All right, next problem. We are given a circle and a small circle with inside of it. We want to know the area of the shaded region, so basically the gray region. And it's lagging again. Great. We want to know the area of the shaded region, and then we also want to know the circumference of the outer circle, the circumference of the outside circle. Okay? So the first thing that we're going to do is the area of the shaded region. To find the area of the shaded region, it's like one of those composites, but instead of adding, you would subtract. So we'd find the area of the larger circle and then the area of the smaller circle, and then we would subtract the two areas. So in order to do that, we need to know what is the radius of the larger circle. So right now, I know that the diameter of the small circle is at 20 meters. The diameter of the small circle is 20 meters. So if I want to go ahead and split that in half, that means that the radius of the small circle is going to be 10 meters. So what is that going to make the radius of the large circle? 14, right? The radius of the large circle is going to be from here all the way to this end. So we know this right here is 4 meters. If we add that together, that's going to be the radius of the entire large circle. Okay, so for our large circle, and I'll go ahead and do this one in green. For our larger circle, we're going to do 14 squared times 3.14. 14 squared times 3.14 for that area. And that's going to come out to 615.44. Then for our small circle, for the small circle, I'll do that in purple. For the small circle, we're just using the 10. We're just going to use that 10 for the radius. So 10 squared times 3.14. And 10 squared times 3.14 is going to come out to 314. And like I said before, we're just going to subtract those two values. We're going to find the difference between those two values, and that's going to give us 301.44, and that's meters squared. Okay, again, you take the area of the whole entire large circle, take the area of the small circle, and subtract them. You're taking it away. Okay, for the circumference, you need the diameter of the large circle. So what's the diameter of the large circle? 28, right? The diameter of the large circle from this point to this point, we've got a 4, a 20, and a 4. So 4 plus 20 plus 4, if I add those together, that's going to come out to 28 for the diameter of the large circle. So I'm going to take that diameter, that 28, and I'm going to multiply it by 3.14. And that's going to come out to 87.92 meters. Yes, Alex.
So you're saying basically you have like either two goals, the area will like it's two goals in the circle. Sometimes the area would change with the circumference to the stay the same.
Well, yeah, the circumference of an outer rim is going to stay the same, whether you've got a hole in it or not. Okay, the area of the figure will be different because you're removing part of it, but that doesn't change what the outer rim of the circle is going to be. Okay. All right, The last problem, there's two ways that we could do this composite figure. We could just say, hey, it's a trapezoid. I'm going to add 7 and 11 together to get 18, and I'm going to do 18 times 4 and then divide that by 2, and I'll get my 36. Or you can break it up as a composite shape, which is technically what they're wanting us to do. So if I were to break it as a composite figure, I would have a rectangle, and the rectangle is 4 centimeters by 7 centimeters. And then I would also have a triangle, and the triangle is also 4 centimeters by 4 centimeters, right? Which makes sense because this whole entire bottom is 11, isn't it? But we know from this point to this point, this is 7, which means this has to be 4. 7 plus 4 would make that whole 11, right? So they're technically wanting you to break it up into those kinds of parts. So if we find the area of the rectangle by doing 4 times 7, we would get 28 for the rectangle. Then for the triangle has the same exact measurement by 4, but then we have to divide it by 2. So 4 times 4 divided by 2 is going to come out to 8. And then we would just add those together and get 36. Which is the same exact thing if you were to do the trapezoid formula. Again, 7 plus 11 gives you 18. 18 times the 4 is going to give you 72, and 72 divided by 2 will give you 36. So either way that you do it, I have no problem. Okay? Any questions about the warm-up? All right, so let me go ahead and let's turn it to the back. And I've got a question that I'm posing to you, and this is a realistic thought. I want you to think realistically. Don't be goofy middle schoolers like you like to be sometimes. I want you to think real. The Metro Atlanta area. So we are considered to be a part of the Metro Atlanta area. Did you know that? All right. Some people do, some people don't. We are considered part of the Metro Atlanta. So Metro Atlanta area has a population, as of last year, as of 2021, the population for the Atlanta Metro was 5,911,000. And it's spread across a land space of 8,376 square miles. Shanghai, China has a population as of last year of 24,890,000 people. And it only has a land area of 2,448 square miles. So I want to know, how is it mathematically possible for Shanghai to have more than 4 times the amount of people in just 1/3 of the space? So they have 4 times the amount of people in 1/3 of the space. Think of it as, see how spread out we are? Now imagine that we multiply the number of kids we have in this classroom by 4, and we divide the class into 1/3, the space into 1/3, and we cram everybody in there. How is it possible that they are able to live that way mathematically? Think about the unit that we are currently in. How is that possible? And I want you to discuss it with your table mates. Okay, which table would like to share with me what they believe is a reason as to how this is mathematically possible? Don't make me regret this. Alex?
We think that they're using like less in a square inches of space, like the box coffin.
Box coffins?
Yeah, it's like box coffins are basically like very confined. There's like 20 people inside one house, and they only get like 5 feet of it, and they share.
Okay, that's not exactly how it is. Let me just. Somebody have a different answer. Maya.
My answers are kind of dumb. I was gonna say either like they all have really, really like tiny space somehow, or like
Okay, so let's change the perspective then. Instead of it being Shanghai, it's exactly the same idea in New York City, guys. It's the same concept. So think, what does New York City have? that we don't. Bridget. Tall buildings, guys, tall buildings. So let me put it this way. Raise your hand if you live in a house. A house meaning you've got a front yard, a backyard, side yards. You are not connected to somebody. You live in a house. All right, great. Raise your hand if you live in an apartment. Now keep your hand raised, those of you living in an apartment, if your apartment building is more than 11 stories tall. See? Does anybody live in an apartment building more than 11 stories tall? No. Here's why. So write this down. In Atlanta's metro area, we have a lot of single family homes, or we've got apartments, but the apartment complexes tend to be 2, maybe 3, possibly 4 stories tall. They don't really have a whole lot of it. So in Atlanta, we do have tall buildings. There are tall buildings. In fact, we have exactly 39 high rises or skyscrapers that they're considered. It's considered to be a skyscraper if it's more than 50 stories tall. That's a skyscraper. So we have 39 skyscrapers here in Atlanta. But essentially, Atlanta has just over 256 buildings that are 11 stories or taller. Now, the majority of these buildings that are 11 stories or taller, they're mostly commercial use. What that means for commercial use, it means that people work in them. In fact, one of the well-known skyscrapers here in Atlanta is what used to be SunTrust Plaza. It's now called Truist Plaza. It is a skyscraper. The Bank of America building, those are the skyscrapers. Those are banks. They are commercial used buildings. People don't live there, they work there. Okay, now, Shanghai has over 20,000 buildings. That are 11 stories tall or higher. And they are used residentially. You don't have short little apartment complexes in Shanghai or, even within New York. Majority of your buildings are very tall and they utilize that space. So if you don't have enough space to spread out, then you build up. When you no longer have space to spread yourself out, then you build yourself up. And that's called volume. That's what they have utilized. So area is the spread. Think of it like a blanket. When you lay a blanket down, how much does the blanket cover? Volume is how much you can fill, how much you can build up in a space. And so when you are in a congested area like New York City or Shanghai, Tokyo, okay, different places around the world, they build up on their buildings and they have some beautiful skyscrapers. But they use that for people to live in. The apartments aren't necessarily that much smaller. Yeah, they are smaller than a single family home, but as far as apartments go, they have apartments that are similar in size, 1,100 square feet or, maybe 900 square feet, depending on how big your home is. Okay, not that far off from what standard apartments are in this area as well. Okay, so they're just using the space upward. So that's what we're getting into. We're talking about volume. We're going to talk about the volume. So volume of any prism, no matter what the prism is, we can use this formula, big B times big H. And big B, I'm going to highlight that in my blue. Big B stands for the area of the base shape. Big B stands for area of your base shape. And then you're going to multiply it by big H. Some of you are getting a little too talkative. You don't need to talk in order to find your color. Okay? Big H is going to represent the height of the prism. Big H represents the height of the prism. And you can find the height of the prism by the measurement. Okay? It's the measurement that connects the two bases. It's the measurement that connects your two base shapes together. So if you've got a triangular prism, it's the length that's connecting the triangle to the other triangle. If it's a rectangular prism, it's the measurement or length that connects the rectangle to its congruent rectangle. Okay, that's what it means by height. Now, please keep in mind, guys, think about it when we talk about how tall you are. Anybody know how tall they are? Maya, how tall are you?
4'11".
4'11". Thank God, I am too. Nothing wrong with that. So now Maya is 4'11". So if she stands up along this wall and we measure her height and she comes out to being 4'11", and then I say, hey, Maya, go ahead and take a nap, and she lays down on the ground, is she no longer 4'11"? She's still 4'11", right? It doesn't matter. She's just laying in a different position. Height, guys, and this is why I'm trying to make sure you understand the emphasis that height is not always from top to bottom. Height is not always going to look like top of the shape to the bottom of the shape. Height is what connects your prism. Height is what is connecting those two base shapes together. So sometimes your shape might be laying on its side. Sometimes the triangles might be on top and on the bottom, but sometimes the triangles might be in front and in the back, and you might be laying on the rectangle side. But it doesn't change the fact that the height is still what connects the two triangles together, or connects these two rectangles together. Please be mindful of that. Height is not about top to bottom. It's not always vertical. Sometimes height might look like it's horizontal. All right, given the following picture here, we have this rectangular prism, and I'm going to identify my base. And it doesn't matter with a rectangular prism which ones are going to be your base. I'm going to go ahead and, for all intents and purposes, I'm going to use the top and bottom rectangles as my base. So I'm going to go ahead and highlight them in blue. So I have a rectangle on the bottom and I have a rectangle on the top to represent my base. What are the dimensions of my rectangle? 5 by 4, right? It's got a 5 by 4 for the rectangle. So what I'm going to do is I'm going to multiply that 5 times that 4, and that's going to give me the 20. There is the area of my base shape, the area of my rectangle. The measurement that connects the rectangles together. I pick any corner on the rectangle. It doesn't matter which corner I pick. I'm going to go ahead and pick this back bottom corner. I'm going to pick that corner, and I'm going to follow the line up to the same corresponding corner on the top rectangle. What measurement is that? 3. That's my height. That's going to represent the height of my prism. It's the value that is connecting those two blue rectangles together. So the height of my prism is going to be 3. So we are going to multiply the 20 times the 3, and that's going to give us the volume in this case. And now volume is going to be cubed. So this is centimeters cubed, just like area was centimeters squared, and circumference or perimeter was just centimeters. Volume is always raised to the third power. So if you need to put right next to volume in the corner a 3, just to help you remember that it is raised to the third power, always, 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 then by all means do so. I want you guys to go ahead and do problem number 2. Let's take a look at this one. So for here, we've got the rectangle. I went ahead and just used the 3 by 1.5 for the rectangle. So I would do 3 times 1 and 1/2. That comes out to 4.5, or you could even say just 4.5. It doesn't really matter. And then you would just multiply that by 6. And then you should have gotten that the volume in this case was going to be 27 feet cubed. 27 feet cubed would be the volume for that rectangular prism. Now, it's the exact same concept. It doesn't matter that it's a rectangular prism. It's the same idea for a triangular prism. So go ahead and look on the second sheet. On your second sheet, triangular prisms. Apparently, Cuddles really likes triangular prisms. Okay. Wow. She's quite vocal today. So for here, for our triangular prisms, again, you're identifying your base shape. Quiet. You're identifying your base shape. So we have a triangle in the front, and then we've got a triangle in the back. Triangle in the front and triangle in the back. Now remember, for the area of a triangle, we only need the base and the height. So what is the base of the triangle? 4. What is the height of the triangle? 3. Okay, that 5 centimeters, that's just what we would call a hypotenuse. It's the measurements that's directly across from a right angle. But when we're looking at the triangle, we're looking at the 2 measurements that are perpendicular to each other. Perpendicular means that creates that right angle there. So in this case, it's a right triangle already. So the 4 and the 3 are what form that right angle, that perpendicular set. That's the base and the height. So we would do 4 times 3, base times height, and then we have to divide it by 2. This is the one that causes the biggest mistakes. Students constantly think, oh, I know what I'm doing, and then they rush, and then they realize they forgot to divide by 2, which is why they get the problem wrong. Okay, so 4 times 3 is 12. 12 divided by 2 is going to give you 6. So you get 6 centimeters squared for the area of your rectangle. What measurement connects those 2 triangles together? Huh? Which one? Which number up here connects the 2 triangles together? 11. The 11 is what's connecting them together. One triangle to the next. Notice again, this is a picture of a triangle that's laying on its side. It's not a triangle up at the top and a triangle down at the bottom. It's a triangle that's laying down on its side. That's still considered to be the height. That is still the height of the prism. So we are multiplying this by 11. So 6 times 11 is going to be 66. So we get 66 centimeters cubed. 6 centimeters cubed, because we're doing centimeters squared times another set of centimeters, which gives us centimeters to the third power. Go ahead and do problem 4 on your own. Taking a look here, we've got the 2 triangles. We've got the triangle that's an 8 for the base and a 3 for the height. So 8 times 3 comes out to 24, divided by 2 gives you the 12. So you have 12 centimeters for the area of the triangle. The height that is going to connect those together is going to be that 12 centimeters. So we're going to multiply that answer times 12. And 12 times 12 comes out to 144. So you get 144 centimeters cubed. 144 centimeters cubed. All right, let's take a look at cylinders and cones and spheres. It's the same idea. Cylinder is definitely a type of prism. A cylinder is a type of prism. So you still find the area of the circle and multiply it by the height of the cylinder. That's the same exact idea. It's just pi r squared times height. A cone. Cones and pyramids follow the exact same formula. You would find the area of the base, you would multiply it by the height of the pyramid, but then you would divide it by 3. And if we have time, I'll show you a cylinder and a cone that are exactly the same diameter, same radius. And 3 cones, if I fill them up with water 3 times and pour them into the cylinder, it fits perfectly. So 3 cones of the exact same base measurement, exact same size circle, will fit inside of a cylinder to the same height. Okay, if the base circle and the height are the same for the cylinder and the cone, 3 of those cones fit inside of the cylinder. That's why we take 1/3 of the measurement. All right, with that in mind, turn it on over to the back. Don't do these 2 problems yet. I want you to now look at the volume formula for a sphere. For a sphere, to find volume, you do 4/3 times pi times r cubed. R cubed, because r squared is area, but we're focusing on volume, and we really don't have a height here. There isn't a height measurement. So you do it to the 3rd power. So 4/3 pi r cubed. What I want you to do is I want you to do the cylinder, the cone, and these 2 sphere problems on your own using those formulas. Here are my answers, so you can check. For the cylinder, you should have gotten 3,014.4 centimeters cubed. For the cone, 234.45 centimeters cubed, because again, you would find the radius, do r squared times pi, but then you have to, and then multiply by the height, but then you have to take 1/3 of it. So you can either multiply it by 1/3 or you would divide it by 3. Okay, so if it was a cylinder, it would have been 703.36, but then you have to take 1/3 of that for the cone. Okay, so you have to remember those measurements. And then for your spheres, for the 2 sphere problems, down at the bottom, the very first sphere, you should have had 523.3 repeated centimeters cubed. You would do 5 times 5 times 5. That's what 5 cubed means, which is 125. You would then do 125 times 3.14 times 4/3. Okay, what's wrong? She's the only one who what? Wants IXL. Well, no IXL today. It's Delta Math instead. I love it. I love to hear you guys be so upset. It makes me want to give you more. All right. Our last one, we've got 3052.08. I bet she wants IXL because she already did it. All right. On Google Classroom, if you go and navigate to Google Classroom, you'll find your Delta Math activity. Go ahead and go.